Okay, so in this video we're going to look at techniques for approximating a different number that is also problematic, just like the square root of 2, where we can easily understand it in terms of its geometry. However, it's not so obvious as to how to express it as a decimal, and that's pi. And so just a review of what pi represents, every circle has the same ratio between the circumference, the distance around the outside, and the diameter, or the distance from side to side through the middle of it. Every single circle is the same ratio, and that ratio is what pi, the number pi, represents. So the idea is that if we take a circle whose diameter is 1, then we're dealing with a circle whose circumference is pi, or the distance around the outside is pi. So how can we determine what that distance is? Well, a very early approximation technique was to say, let's put a square inside of our circle here. And as a gross approximation for pi, because pi is going to be the distance around the outside of the circle, we can use the distance around the outside of the square. Now we know some things about this square because of the diameter that we said was going to be 1. If this diameter is 1, we know this is 1/2, this is 1/2, and similarly we have 1/2 and 1/2. You'll also notice that these are all right angles. So this is the side that we're interested in. 4 of them will give us our first approximation for pi. And if we take one of these triangles out here and look at it, if we have this, you may recall relationship that's true in all right triangles from the Pythagorean theorem that says the sum of the square of the sides is equal to the square of the hypotenuse, or usually it's said a squared plus b squared equals c squared, but in this case it's going to be 1/2 squared plus 1/2 squared equals that side squared. This adds to 1/2 equals the side squared, so that means that that first approximation for one side is going to be 1 over the square root of 2, or the square root of 2 over 2. And so then the first approximation will be 4 times this, 4 times the square root of 2 over 2, or 2 square roots of 2. And that would be the distance around the outside of this square. So obviously that's not a very good approximation. In fact, it's an under approximation, right? We've got all this distance that we haven't. If you think about this this square, there's quite a bit of distance. If this were a piece of rope, you would have to stretch it to get it out here. You would need more distance out of it. So a better approximation still would be if we were to pop some little triangles on each side of this square and find the distance around the outside of that. And better still would be if we were to pop some more triangles on there, and to continue that. And eventually what we'll do is what's called exhausting the circumference, or the area inside of it, which will give us a better and better and better approximation for the number pi.